Hey students, this is Junior Scientist and we are going to resume our discussion from the which was about separation of different mixtures and solution, and today's topic is about separation of immiscible liquids. Now you should be clear about something what we could call it as immiscibility. Remember that there are the two major categories in which we can divide the liquids or solutions. In a simple way, the immiscible solution is the one in which something is not purely or entirely soluble with the other stuff. So, and in the miscible liquid is what in which something or the two liquids are entirely soluble within each other. So when it comes to the miscible liquids, it engages. The best example of it is when you dissolve water and milk into each other. You're going to, if you provide it with the heat or not, it is not dependent upon that factor. They are entirely soluble within each other. You can differentiate between where the particles of water are and where the particles of milk are being arranged on. But when it comes to some immiscible liquids, it engages something in which you can identify the two different liquids or the particles of two different like solutions or liquids. So the best example of this is the presence of oil and presence of oil, or you could say that presence of oil and water. Sorry. So when you dissolve kerosene oil or any oil within water, they will be constituting something which is called as immiscible liquids. So they would create some sort of different layers. Why they would create different layers? Because they are engaging some differences on the basis of density. So they would separate themselves on the basis of density. The one which is having higher density would stay right at the bottom. The one which has lower density would stay on the top. So we will later on then do some sort of strategies by using simply the separation funnel is the most easiest technique to separate them, because honestly, if you have to compare the miscible liquids and immiscible liquids, the separation of immiscible liquids is quite easiest way to separate them two. You can simply use the separating funnel to separate the two. But when it comes to the separation of the miscible liquids, you have to apply different strategies, either evaporation methods or crystallization, or various strategies to separate the two mixes from each other. But in this case, you have to simply place them and they would get separated on the basis of the density. The one which is more denser would stay at the bottom because it would be high, it would be attracted by the gravitational force, by the gravity, so the gravity is going to attract them. But the one who is having lower density would float at the top and it would be comparatively lesser attracted by the gravity. So that was an overview. Now next is the case, it's like separation based on the mixtures of solids. So if you have the mixtures who are soluble into each other or might not be comparatively soluble into each other, but simply they are creating some mixtures of the solid, and how you could separate them, you could separate them by basis of their density upon the basis of their magnetic properties. So these are the two general overviews of separating them. Now I am referring to something which is called as what the separation based upon the density differences in the density. So in this case, we would refer to the gold particles, but they are saying if you refer to the gold beds who are present in Amazonia, how you could separate them, because the gold particles who belong to that particular area are comparatively of higher density in comparison to the other metals or non-metals. So definitely we will place them within a solution, and gold particles would be attracted to the bottom right under towards the gravity, so that we could separate them. The next example over there is like this type of method is used in purification of the ores of zinc. Remember that there is a term ore. Ore is referred to the something which is present along with its impurities. Now, a zinc is present in some combination of something. Either it is present in with along with sulfur, oxygen. It would be the ores of zinc. So we have to like get rid of other metals or non-metals in order to make zinc pure. Next thing is simply we could use the processing or like differences on the basis of density in order to separate different ores. or zinc and copper from each other. So the metal which is more denser would float on the surface, and the one who is having lower density would came to the bottom. It would be available right onto the bottom because of its higher density. Next property is about the separation on the basis of the magnetic properties. This property is best known because if you have some magnets and non-magnetic materials, you can easily separate them. Let us say I have a mixture of salt, sugar, and some magnets. Now I would like to place magnet onto them. What it is going to do is it is going to do some sort of attraction towards those magnetic properties, and due to those magnetic properties, the thing which is magnet will be straightly attracted towards the magnet, and that is how I could separate them from each other by using any harder processes. There is a bit demonstration for the separation of immiscible liquids on the basis of their density. Now, the first method is, or the first step is, the mixture of immiscible liquids would settle into the two layers as the liquids do not mix. It means they are obviously they are immiscible. They are not going to mix anywhere. So as soon as you pour in the mixture, the one who and allow them to settle, this guy will be having more density. It would be available right onto the bottom, and this liquid maybe in case of water, in case of water, or what you could say that water and all mixing up, so simply one would stay at the bottom and the other is going to stay right onto the top. So what you are going to do is you have to open up the tap. This tap would allow this bottom layer to pour into this container, this beaker. So this layer number 2 would be poured directly into the speaker. This is entirely going to tie into this beaker. So we will be getting rid of the solution number 2, or the mixture number 2, and the one who is having lower density, who is available right onto the top, would stay above. So that is how we could separate the two on the basis of their density. Now, in this case, they have placed an oil which is having a lower density in comparison to the water. So it could be of any type. So this would be available right onto the top, right there, and this water would be available right there. So that is how we are going to open up this knob-like structure. So as soon as you are opening it, we are going to allow this to move downward into a beaker step by step, drop by drop. As soon as we feel we are done with the separation of this liquid or water, the oil would be left off, and later on we could collect it. So that was all about till this point, or separation on the basis of their density. The next procedure is separation based upon the basis of the differences in solubility. Remember that when you have two liquids, or when you have two solutions who are mixing up into each other, you should be clear, like if you have two solute, at least one of the two solute must be having some sort of attraction or solubility with one solvent, and other must be insoluble into it. What do I mean by this thing? It is the case because solvent is going to make one solute soluble into it, and the insoluble will obviously stay right there. The major process is like the mixture is first ground to a powder. Let us say I have a mixture of salt and magnet again. So I am going to ground them, I'm going to mix them up. Later on, I would find a suitable liquid, or a soluble solvent. What is the role of this solvent? The role is that it must be soluble with one of the solute, and it must be insoluble with the other. So again, if we refer to magnet plus salt solution, it is going to be soluble with the salt because it is water. So simply, in case of salt plus magnet, water is going to be soluble with the salt. The thing is, the magnet or a suitable liquid solute is being added. The solvent must dissolve one of the solid substances present, but not to the others. Again, the same thing they are saying. The solvent is often water, but the other liquid must be taken carefully, because if you are going to take ethanol, you must consider the solubility fact, like at least one solute must be soluble within that alcohol, another must be insoluble. Next is the case. The K must be taken at the warming stage when using solvents other than water. So if you are going to warm the solution, you must be careful. Like you don't have to make it too hotter. You don't have to keep it too lower. So that at least you should keep the temperature till a point like when these two are the two who are being going to soluble into each other must be allowed to get soluble into each other. Okay. Now all the soluble particles. I mean like. Water has now been converted into the salt solution will be just evaporated. The leftover would be the magnet. So that is how we could separate the residue from the given mixture. Again, we are going to pour the solution onto the filter paper. Remember that filter paper is a paper on which minute particles or minute spores are present or pores are present. Those pores are going to allow water to pass out through them so that it could left off soluble particles which it carries on it. So later on, in case of the entire mixture, magnets would be staying at the filter paper and it would be now allowed to dry in. The soluble substance is in the liquid filtrate and they would be allowed to pass it through the filter paper. The dry ice can be obtained by evaporation and crystallization. Dry crystals could be separated by the process of crystallization. Remember that in order to do the crystallization, first you have to convert the solution into the concentrated form. After converting it into the concentrated form, you have to allow it to stand. When the solution key stands on, it is going to left out with some crystals. Later on, when we are going to pour it or pass it through the filter paper so that it could absorb all the crystal onto it, and that is how we can separate the crystals from the given solution. The next strategy is using separation, and separation is based on the sublimation. Remember that sublimation is when a solid is directly converted into the gaseous form, and obviously we can separate something if we are mixed of 3 to 4 particles. At least one of them would be having this property to sublime itself, so we can separate it. Usually, this property is referred to the dry ice, which is carbon dioxide. So we can separate them. The next point is separating solution. This strategy is used like the separation of this type of mixture is often slightly more complicated because there is no physical separation. The method is it depends upon the solubility properties or maybe the differences in the boiling point or volatility. Remember that when a solution needs lower boiling point to boil itself, it is going to be more volatile. And when a solution needs more boiling point to boil itself, it will be the less volatile. So if we just compare boiling point of ethanol, ethanol needs 78 degrees Celsius to boil itself and water needs 100 degrees Celsius to boil. It means ethanol is more volatile but and water is less volatile because they need alternative boiling point. Now when it comes to this process, the solution or the separators is going to demonstrate how we are going to separate mixture of ammonium chloride from like sodium chloride, because sodium chloride ammonium chloride would convert itself into the gaseous form as soon as it is going to sublime itself. So once it is the solid particles right there, if we just refer to the spec, like right there we are going to place ammonium chloride within the solution. It is in the solid form. We are going to provide it with the heat. It is going to heat itself, but from above, from this way, we are going to condense it. As soon as we condense it and from downward it is provided with the heat, it would convert itself directly into vapors and it will sublime itself. So that is how all the particles of ammonium chloride would attach to this particular condensation tube, and we are going to left off with something which is called as sodium chloride. Okay, so that's it till this point. I hope today's lecture would be clear to you. If you have any queries, any confusion, you can text us and try to subscribe the channel if possible. So in today's lesson, we just learned about some strategies to separate the solution from each other. Mostly they were covering the different techniques related to the immiscible solutions, and we just learned of separation related to the density, to the magnetism, to the basis of sublimation, and also basis upon the density, crystallization, and different strategies. So that's it today. Thank you. See you soon. Good luck.